Projectiles A, B, and C are simultaneously thrown off a cliff and take the trajectories shown here. Neglecting air resistance, rank the times TA, TB, and TC they take to hit the ground. So, when talking about projectile motion and stuff like launching a ball, you should probably remember that the horizontal and vertical components of the velocity can be separated. So they can be decomposed and they are independent of each other. So now if there is no air resistance, then the x velocity is going to stay the same. But the velocity in the x direction or horizontal direction does not really matter because gravity does not act in the horizontal direction. Gravity only acts on this vertical component. So gravity is going to be accelerating it downwards. And nothing affects the horizontal component, only the vertical component matters. So the time in the air is determined by the initial vertical velocity. And it also depends on how high they go. Since if you have a greater vertical velocity, then you're going to go higher before you start falling back down. So the one that reaches the highest height is going to take the longest to fall down. So based on that, the time for projectile B is going to be greater than the time for projectile A, which is going to be greater than the time for projectile C. Since B has the highest apex, followed by A, and finally C. And that is how you would solve this problem here.